Hello, welcome to another video on LaTeX programming and typesetting. If you want to produce an output that is given in the box here, this mathematical expression contains many fractions and many complex fractions. Okay, this kind of complex fractions can be very carefully, it can be typeset without any error, but you have to analyze various parts of this expression. So first you have the centralized form, this mathematical expression in the centralized form, and the first part is a fraction 4 over pi, and after that you have equal symbol, and then you can type 1, after that plus, then you have a fraction. Then in this fraction you have the numerator is 1 square. 1 square is the numerator, but the denominator is another expression. This is the denominator. So you have to type the command, use the command /frac, then in the first curly bracket you can type this 1 square, and in the second bracket you have to type this. But for typing this you have to take care, because that itself is a fraction, and that continues, and that is continued to the next step. So okay, and you can produce the output. This output can be produced using this part of the source code. Okay, and that is /begin equation star, then you have the /frac for in first bracket, then in the second bracket /pi, because pi can be typed using /pi command. Okay, so /frac, then 4 in first bracket, then /pi in the second bracket. After that equal symbol, and then 1 plus, again you begin a /frac for this fraction, /frac, then 1 cap 2 in the first bracket, but in the second bracket you have, in the second curly bracket you have 2 plus once again you begin that /frac command. /frac, you use the /frac command, there you have 3 square, 3 cap 2, and then in the first curly bracket you have 2 plus, then one more /frac command, /frac, and then 5 cap 2 in the next curly bracket. After that you have 2 plus then dots, so /dots b for getting that dot. Then properly you have to close the curly brackets. So how many you have to close all the curly brackets that are opened. So there are 3 curly brackets are simultaneously used to close that. Then you have /end equation star. Okay, we can now copy this portion in the program, and just take the output. No error. So yeah, that output you can see here. So correctly that output, but only that difference is there. The square portions are not properly obtained there. That can be done, can be changed. Correct cap can be given. Once again I shall take the output. Okay, now it's okay. The output, you can see that output. Okay, next we have if you want to typeset this expression, but okay, and that actually here what you can see is actually required expression is this, but instead of you are typing where if you carelessly type that, then you are going to get this output. So this output is shown here to explain that errors that may occur while you typeset. You can see this the source code part, and if you type that source code part in this way, you are going to get this output. That's what they explain here. Then we come to the part affixing symbols over a number, or affixing symbols over or under. Okay. Yeah, okay, affixing symbols actually over or under some symbols or some letter, like some letter or something like that. How can we do that? You can see this expression. If you want to produce this expression, what we have to do, you have to check whether any package is required for that, some special package thing like that. If you require, then you have to include that package. No, it is I think there is not mentioned about that. Okay, AMS math package, here it is mentioned. See, you have to include that AMS math package. The AMS math package is also it provides the commands over this kind of commands are provided by that package, AMS math. So you have to check whether that package is already there, included in the program. See, AMS math, okay, use package AMS math is there in that program, in the beginning of the header part of that program, that is included. So you can try whether you are going to get this 0 is okay. First let's analyze that source code /begin equation star, then 0. First in that environment we put 0. Then this for producing arrow mark, you can use /x right arrow. See, /x right arrow, then in is the command used to produce that that arrow. Okay, then curly bracket we have that curly bracket. After that, you type then /right. So see, in that command, in that /x right arrow, since we are not using anything over that that arrow, so that curly bracket is left blank now. But in the second case, you have /x right arrow, there f will be typed over that. So you can give that as an argument inside that curly bracket. So f is typed there, inside the curly bracket. After that, you type b, then again /x right arrow, then g can be small g is typed inside that, then another arrow without any typing over or below. So you can use just that c x right arrow, and then after that 0. So by that you can end the end that mathematical environment. So I am going to copy and run it. Let's take that let's take the output. Yeah, you can see that along with that running matter, you can see you don't have to worry about this, because it is very simple. But if you want to produce this output, that the command part is important, that so you have to go through it once again. I shall show that, and this is the command part that produces that mathematical expression. This use of /x right arrow command along with that curly bracket. If you want something to be typed over, something to display over that arrow, then you have to give it in that curly bracket. Okay, what is there? So if you want to give something just below that, that also we can go through that type of creating output in this video itself. So look at this output here. You can see below that arrow you have to type this monic, and then below in the second arrow, below part the bottom of the second arrow is filled with the EPI, some material EPI. Okay, for that what can we do to obtain this? For that you have to use the source code. You have to type the source code as given here, /begin equation, then 0 /x right arrow, then empty curly bracket, then a, and then /x right arrow. After that you have to use the square bracket. You have to use the square inside the square bracket, then /text, then monic, MONIC, because it's an ordinary matter, as it appears not in the as a mathematical expression style. It's an ordinary matter, so you may include the command /text. Inside that you have to type the entire thing, MONIC. After that square bracket can be closed. Then you have the curly bracket in which you can type F, because that appears just above the arrow. And in a similar fashion you can type B, capital B. After that you can type /x right arrow, /x right arrow. In the case of that opposite arrow, you can type /x left arrow. Okay, /x right arrow. After that the EPI must be typed below. So for that, in square bracket /text EPI, in curly bracket EPI. After that another curly bracket you can type G, and then C. After that again /x right arrow, then curly bracket and 0. You can now end the mathematical expression. So we type it and take the output. After typing it and taking, you can take that output, and there is no error. So you can see, the output. You can see that output which is displayed here. This is the output that we can create using that source code. Next you see, and a similar situation. See 0 left arrow A, and okay, what is the difference here? That the source code that creates this output here they have used some different source code, or some space command is used there. For what? For producing space in inside that mathematical expression. Let's go through that. Okay, we can go through that. So by the here okay, the length of the arrow is also here varied. Okay, that length you can see compared to the previous one. Here this expression actually here length of the arrow is decided by the matter that is used just above or below the expression. But here in the other case, if you want to, in this case you have longer arrows. So for that it is explained here by the way, and we would not it be nicer to make the two middle arrows the same width. Okay, here you can see it's of a varying width, but it will be nicer if you can make both arrows of same width, and this can be done by changing the command for the third arrow. By changing the command for third arrow, that is the one from B B from the letter B as shown below. So see, slash begin equation star, then 0 slash x right arrow curly brackets, then A slash x right arrow, and then slash text monic, text in monic in bracket, then F. After that B we have slash x right arrow. See that for changing that length of the arrow here, the additional command h space slash h space is used, slash x edge right arrow, and then in square bracket you type slash h space, then a 7 point. So that 7 point actually decides the length of the arrow. Slash h space, then 7 point, then matter continues slash text epi, then again slash h space 7 point. So you have to give 2 places from the beginning, from the that's on the left and the right of that slash text epi to get that effect. Then G, after that C, and then X right arrow. Okay, then closing that bracket, closing that, and then finally 0. Okay, then finally, and the mathematics environment is closed. Now we copy and paste it. Let's take the output. You can see that length is now increased. The length is increased, but it is it's something very advanced type of material. So just I explain here just to give you some an awareness only. So okay. Now we have that you can see here 2 different outputs given. We can go through that also before we close that this material. This video. Before closing this video, we have to go through this output. Here you can see in this box an output is given in which you can see this symbol is very is appearing in just like that summation, the sigma, and you can see here that subscript and superscript as ordinary subscript and superscript, they are not coming at the lower and at the top, at the just bottom and the top of that symbol. So that difference is due to the typing, that a special type of command that we use inside the source code. Now you can go through this. Then you know if you use this dollar symbol, single dollar, and then slash sum and that underscore n equal to 1, then the cap infinity, cap slash infinity. If you want to type infinity, then you have to use slash infinity, cap slash infinity, then fraction, frac slash frac, then 1 and n cap 2, the dollar converges, but also that so you have finished the typing up to here. Then you have that in mathematics environment slash begin equation, then sum slash sum and the underscore n equal to 1 in curly bracket, then cap infinity slash infinity, but you have to type infty. That short form can be used, slash infty, to get the infinity, slash infty, and then slash frac 1 slash frac 1 and n cap 2 equals slash frac pi slash pi slash pi cap 2. Then we have 6 in the denominator, so fraction. This can produce fraction. So let's copy and view the output. So manually we want to change the caps, all the caps. Okay, I have done that. So now we can take the output. Okay, that is gone to the next page. Okay, on the second page actually we have to go to the second page to see the output. Yeah, on the second page we have the output is shown here. We get that output as shown here. So here the difference, you can compare these two summation symbols. Here the subscript and superscript appears in this way, and but in this expression you can see that difference. It's because that is used inside that inside a different mathematical environment, begin equation star. In that environment we use, so we get that difference. Okay. But if you want to produce that effect, the similar effect here also, you can typeset that using you have to make the change here as shown, as given here. So see, instead of typing this, you have to type slash dollar slash display slash dasplay style, display style, and then display style, then slash sum, and then underscore n equal to 1 in curly bracket, and then cap infini infty, then slash frac 1 in the first bracket, then n cap 2 in the second bracket. So that can be, if you type instead of this source code, if you type the source code which is given here, you can obtain this output, this effect in the output. You can obtain the output as given here. Okay, so that you can notice, that you can note. So the difference, you have to give additionally, you have to type slash display style just before that slash sum command to obtain that changed output. Okay, with this we are going to wind up the video. The remaining can be will be explained in another video. Okay, remaining topic to be discussed. Okay, thank you.